we're going to the Mauna Loa Observatory, and this is where the carbon dioxide readings come from. And I'm like, I gotta go see that place.
When it comes to office views,
Thanks for having us out, man.
Yeah, of course.
Aidan Colton is crushing it. We visited him before a recent volcanic eruption temporarily interrupted operations up here.
It's not the easiest place to get to, as you can see.
No, it wasn't that easy.
It's not the easiest place to work. It's 11,000 foot elevation. You know, every time you take a breath of air, you're breathing in a third less oxygen.
Too much carbon dioxide in the atmosphere is what drives climate change. And for the last 65 years, scientists around the world have relied on the carbon dioxide measurements taken on Mauna Loa. Aidan is the guy who takes them, and he invited us to come along.
This is the Carbon Cycle NOAA portable sampling unit. And what we're doing here...
Kind of looks like the nuclear launch codes might also be in there.
Yeah. Luckily, they're not.
Aidan's telling me the air up here is what makes this remote location so important. We're more than 11,000 feet up, far above any ground level pollution from communities below, and we're surrounded by 2,000 miles of ocean. So by the time air makes its way here, it's been blended with air from across the globe.
All right, so we'll just hold our breath, just because that's what I usually do when we get like 10 seconds. But once I close it off,
We have to hold our breath?
it's very hard to affect it, but we don't want to contaminate.
Tell me when I have to hold my breath. I looked over at you and I'm like, I don't think you're gonna be able to do this. Chance. Hold your breath.
I couldn't hold it. I had to breathe.
These samples gathered once a week will be sent to a lab for analysis. There's also a tower another 140 feet up that pulls and analyzes samples 24 hours a day, determining how much carbon dioxide is in the air at such a high altitude.
You have all this research from this location. What story does it tell?
Our job is to present the facts. And the fact is that carbon dioxide is increasing, and it has been increasing since we started monitoring it.
Starting in 1958, this graph of samples taken in Hawaii shows the concentration of carbon dioxide in the atmosphere rising year after year after year. Now let's go back in time by 800,000 years. By studying things like ice core samples, ocean sediment, and tree rings, scientists have a good idea how much carbon has historically been in the Earth's atmosphere. It goes up and down over time, but it's never crossed this line. And now, let's bring things back to what's happened in the last 65 years.
The CO2 in the atmosphere has never been seen this high in human history. It's harder and harder for me to speak to people like yourself and be optimistic. I want to see some change, and I want to see it start to plateau.
So we've got a lot of carbon dioxide. Now let's talk about where it's coming from.
So I think this next stop would be pretty cool. This company has figured out how to visualize carbon dioxide. Hello!
Davida Herzl is the CEO of Acclima. In Oakland, her company operates a fleet of cars outfitted with tubes and sensors that analyze the air for 14 kinds of pollution. One of them is carbon dioxide, which floats straight up into the atmosphere and can stay there for hundreds of years.
To deal with climate change, to deal with air pollution, you really have to understand where it's coming from, and you have to take local measurements to do that.
As we're driving, how many measurements are happening right now?
Right now, every single second, we're taking a measurement.
Off this hose?
Off of that, yeah, the air is getting sampled. We're moving through the streets. That enables us to pinpoint the precise location of those measurements.
There are a lot of ways that carbon dioxide gets into the air, but according to the EPA, the #1 source of carbon emissions is transportation at 27%.
You can look out the window. I can count 1, 2, 3, 4, 5, 6, 7, 10 trucks just in front of us right now.
Diesel trucks.
Diesel trucks. And what you're looking at here, that's the CO2 coming off of these trucks.
What she's showing me is a visualization of carbon dioxide on the streets of Oakland. The lower concentrations are purple on the side streets. The much higher yellow levels are freeways. And those things that look like skyscrapers are emissions where two highways come together. Businesses and governments use Acclima's data to identify and reduce sources of pollution.
this isn't just an invisible problem. You can now see it. It's visible. It's measurable.
And when I drive,
and when you
I
drive,
contribute.
you're contributing. You're putting CO2 into the air.
So the level of carbon dioxide in the atmosphere has exploded, and transportation is a major contributor. But why is carbon dioxide a problem?
We're trying to get an idea of how this greenhouse effect works. How does CO2 have this power over controlling the Earth's temperature?
Dr. Eugene Cordero is a climatologist at San Jose State. We're meeting up at a science museum in Oakland, and he's going to help us understand the greenhouse effect, where carbon dioxide functions like a blanket around the Earth. He's telling me as the Earth naturally radiates heat, the carbon dioxide in the atmosphere retains some of that heat, and that's what makes the planet comfortable. His demonstration here involves a candle, a camera, and a piece of glass.
So you were kind enough to bring a candle. I also stopped and got a few candles.
Oh, cool.
Fresh lavender breeze.
Oh, that's
That one
nice.
smells pretty good.
Yeah, so we're going to have a heat source. This like represents the Earth. So the Earth gets warmed during the day by the sun, and then it gives off energy. So we have
This is
our
the heat
energy
of the
source.
Earth?
Yeah, right there.
Okay.
So we have our planet right there.
Okay.
And then we have this camera, this special camera that senses infrared radiation or heat. And that's like a satellite orbiting the planet. To be honest, that's the best way to measure this greenhouse effect.
From space.
From space.
Like, is this our carbon dioxide?
Yeah, it behaves in the same way because it absorbs this particular type of radiation.
So I'm going to basically put the carbon dioxide
You're going to put this blanket of carbon dioxide
in between the Earth and the satellite in space.
Yeah.
It just disappears.
Take a closer look at the candle. The wavelengths of heat show up as white, red, and yellow. When the glass comes into frame, it shows up as solidly purple, so you can't even see the candle behind it. Dr. Cordero is saying when you add more carbon dioxide to the blanket around the Earth, our planet retains more heat.
Our natural light from the sun passes through, but then the infrared radiation on its way out
Can't get out.
can't get out. But now we have a lot more CO2 than we used to, and so our planet's temperature is going to go up. It's a great thermostat.
Now let's take another look at that graph from Hawaii. This is the line that shows carbon in the atmosphere going up and up. Now add in global average temperatures. As the carbon dioxide rises, the temperature rises too. Dr. Cordero says a large body of research shows us that is what's driving extreme events like fires, floods, and drought.
How long have we known that carbon dioxide can do something like this?
Yeah, over 100 years.
Over 100 years.
Yeah, so the CO2 and other greenhouse gases is the largest contribution to changing what our planet's like right now and making it warmer. There's other factors too, but carbon dioxide is the number one.
How worried should I be about that piece of glass?
I think this is our main social environmental challenge for humanity.
When it comes to climate change, carbon dioxide is an invisible problem. But we've seen, with a little imagination, it's not impossible to understand what it's doing up there, where it comes from, and how we have more and more in the atmosphere every year. Together, we're going to explore how changing the climate changes our world and what we can do about it. I'm David Schechter, on the dot.
A lot of really good information there. The graphics enable you to actually see it, not just talk about it.
It's a great way to explain it.
Absolutely, and it's a big issue. You can feel that it's more actionable once it's easier to understand.
Let's bring in Lonnie Quinn now. Lonnie, I know you had a chance to talk to David. How did he say all of this relates to our area?
Okay, well, look, what's taking place in California, okay, it's not just California. This is a worldwide thing that we're looking at. But from California, things are flowing in our atmosphere from west to east. It's some of the things that we get a chance to talk about. But I had a professor in college who was saying it's not just necessarily like a blanket, that carbon monoxide blanket or dioxide blanket. He also referred to it as a mirror. The heat that we generate bounces up and comes right back at us. So, look, this is an important topic to be talking about. And you heard David say the sharp increase in carbon dioxide in our environment is making for just more extremes. And that's being felt in our area and also all across the country, all across the world. David Schechter joins us now. David, thank you very much for being here. Now, we can tell from the picture behind you that you're in California, where you guys are seeing some of the impacts of carbon dioxide that you just spoke about. Can you talk us through a little bit more of the extreme weather that you're experiencing?
The weather here for the last several days has been, there's just tons of rain, wind, there's less flooding in a lot of these neighborhoods, trees are down, and these are the kinds of storms that are not irregular. They do happen out here, but the fact that we have more carbon dioxide in the atmosphere, like we just saw in that story, makes it warmer in the atmosphere, puts more moisture up into the air, and makes these storms a little bit more, gives them more potential for heavier rain and flooding. It's sort of like steroids. If you have someone who can hit triples, and all of a sudden they're taking steroids and they can hit a home run. It didn't make a great hitter, but it made them a little bit stronger. So climate change is sort of just juicing the odds here.
And in our area, we are seeing a bump up in our extreme weather as well. Can you connect the pieces?
Definitely. So the whole, the story we just watched, and thank you for everybody for watching that story with us, is the atmosphere is warmer, and so you will get those changes. You will get East Coast storms that carry more moisture. You will get hurricanes in the Gulf of Mexico that carry more moisture because there's just more water in the atmosphere, and that's what drives these heavy storms. And I think it's really, it's complicated science. It can be, but the connecting of the dots from being on top of Mauna Loa, the volcano, where they just see the carbon dioxide going up year after year after year, and you see the temperatures going up year after year after year. This is the result. We do get more extremes.
Yeah, and look, numbers don't lie. They just give us data, right? I hope everyone's takeaway is do your piece, okay? Do your little piece of it is, because a lot of little changes can make a big change overall. I want to thank you for joining us here, and David, it means a lot to have you covering these stories to get the word out even more so thanks again.
Great to see you. Thank you.
All right, and coming up later in the show, my good friend and just a sharp meteorologist in his own right, Giorgio Panetta, is going to join me. He and I are going to talk about the extreme weather events right here in our area and why it looks like he and I may be rearranging, I should say, our forecast for this winter. Guys?
Wow, that's striking. All right.
All right, guys, it's all yours. We got it coming up a little bit later.
You bet.